Okay, hi there. So in this video, what we are going to talk about is how to factor expressions using the what we so-called common monomial factoring. But first things first, it must be clear to us that this kind of method in factoring is only applicable if there exists a greatest common factor between the terms of the given expression. So now here are the following steps that you need to do if you're going to use this kind of factoring method. First is to find the greatest common factor or the GCF among the terms. Second, that GCF that you found out will now be your first factor. And to find the other factor, what you need to do is to divide the terms of the expressions or dividing the whole expression by the GCF that you obtained, and the quotient now will be your second factor. And the third step is you can now rewrite your expression as the product of the two factors that you obtained. And then lastly, to check whether your answer is correct, multiply those factors that you obtained and the result must be the same as the expression given at first hand. Okay, so let's do that using this first example. We have 8a plus 10a squared. Okay, so we have 8a plus 10a squared. Now, if you're having a hard time in identifying the GCF between the terms, you can use this long method, which we call as prime factorization, wherein you are finding out the prime factors of the terms of your expression. So let's have, for example, we have 8a. 8a can be splitted as 8 times a. 8 can still be splitted as 4 times 2. And you will not stop until you reach prime factors or prime numbers. 4 can still be written as 2 times 2. And there, all of these now are prime numbers. Or when we say prime numbers, the factors of this kind of numbers or expression is only 1 in itself. Okay, so therefore, 8a can be written as 2 times 2 times 2 times a. Now, let's move to the second term. The second term is 10a squared. So, let's split it as 10 times a squared. Then, 10 can be rewritten as 5 times 2. And these two are already prime numbers. So, we'll stop right here. And then for a squared, it can still be written as a times a. So therefore, the factored form of 10a squared will be 5 times 2 times a times a. Okay, there. So we were able to factored out or expand the given terms in our expressions. The next step for us to find the GCF is to select the common factors which exist in both terms. So here we have a common of 2 and then a common of a. And combining these two, we will have simply 2a and then 2a on the other side. So therefore, these two terms, 8a and 10a squared, can be divided by 2a. And therefore, also, our GCF will be 2a. Okay, now for our next step, what we need to do is to divide the whole expression by the GCF, which is 2a. So dividing the whole expression also means that dividing each terms by the GCF. Okay, so divide both by 2a. So 8a divided by 2a, 8 divided by 2 will be 4. A divided by a is simply 1. So no need to write 4 times 1 because still the answer will be equal to 4. Plus 10 divided by 2 is 5, and then a squared divided by a. So we will have, or we will be left with one copy of a, or simply a. So therefore, our second factor will be 4 plus 5a. So we can now rewrite the expression 8a plus 10a squared as the product of the two factors, which are 2a and 4 plus 5a. Now to check if this one is correct, or our answer is correct, we must multiply the factors, which is 2a times 4, that is 8a, because 2 times 4 is 8, and then a, simply copy a because there is no other variable on the other term. Now, next is positive 2a plus times 5a, so that will be positive. So 2a times 5a, 2 times 5 is 10, then a times a will give us a squared. So still it is the same with our given. So therefore, our answer is correct. Now, if you will not be using the long method, it will be easier and quicker for us, or faster rather, for us to find the factored form of this kind of expression. So let's do that without the use of the long method. So 8a plus 10a squared. Now, in finding out the GCF, observe it piecewise. When I say piecewise, observe the GCF between the constant and then between the variables. So between 8 and 10, the greatest common factor is 2. Or the highest number that can divide both 8 and 10 is 2. And then for a and a squared, simply select the one with the lowest exponent, which is simply a. Then again, proceed to the next step, which is dividing both terms by your GCF, which is 2a. And based from our solution a while ago, we will obtain 4 and 5a. So as simple as that. If and only if you can easily identify or select the GCF, it will be this kind of, or it will be shorter this way. Okay, now let's have another example. This time we will be using, or we will be doing the shorter method. Okay, this time let's have our second example. So we are given 16p raised to 4 plus 4p raised to 6. So let's use the shorter way, or the short method. Okay, so in order for us to find the GCF between these terms, let's do it piecewise. So when we say piecewise, we'll be considering the GCF between the constants and the GCF between the variables. So between 16 and 4, the highest number that can be divided to both of this is only 4. So therefore, the GCF between 16 and 4 is 4. And then for the variables, the shortcut here is to consider the variable which has the lowest exponent. And between 4 and 6, the lower exponent is 4. So therefore, the GCF between the variables will be p raised to 4. So now we have, or we obtained our GCF, which is 4p raised to 4. And what we need to find out now is the other factor. And to get the other factor, what we need to do is to divide both our terms, 16p raised to 4 and then 4p raised to 6, by our GCF, which is 4p raised to 4. And then divide both. 16 divided by 4 is 4. p raised to 4 divided by p raised to 4 is simply 1. So no need for us to write 1 since the product will still be equal to 4. And then plus 4 divided by 4 is 1. And then p raised to 6 divided by p raised to 4, following the law of exponent, which is called as the quotient rule. Okay, in quotient rule, when we are dividing expressions with the same basis, we simply subtract the exponent. So 6 minus 4 is 2. So therefore, we will be left with p raised to 2. And here, in our term here, there is a coefficient of 1. If the coefficient is 1, there's no need for us to write 1 beside. It's already understood that the coefficient here is 1. So therefore, the factors now will be 4p raised to 4 and 4 plus p raised to 2. Now to check whether this answer is correct, what we're going to do is to multiply our factors. So 4p raised to 4 times 4. That is 4 times 4 is 16, and then copy p raised to 4 since there is no variable on the other term, and then plus 4p raised to 4 times p squared. So 4 times the imaginary 1 here, that is only 4, and then p raised to 4 times p raised to 2. So p raised to 4 times p raised to 2, following the product rule in the laws of exponent. When we are multiplying expressions with the same basis, we simply add the exponent. So 4 plus 2 is 6, and then copy the common base, which is p. So therefore, p raised to 4 times p raised to 2 is p raised to 6. And still, the product is equal to our given expression. So therefore, our factored form is correct. Okay, so let's have our one last example. Okay, so our last example will be 12a squared at Okay, now let's have our one last example. 12a raised to 6 plus 8ab minus 20b squared. So let's do that here on our board. So the given is 12a raised to 6 plus 8ab minus 20b squared. Now again, to find the GCF, consider the constants present, and then the common variable. Okay, so between 12, 8, and 20, so 12, 8, and 20, its GCF is 4, or the highest number that can be divided to all of this is only 4. Now for the variables, look at our variables. So we have a raised to 6, and then a times b here, and then b raised to 6. Now if you will notice, there is no consistent factor or variable present in each term, so we will not be considering this time the variable. So therefore, the only factor that we will have here is 4, or the GCF is 4 among the terms. Now again, we need to find the other factor by dividing each terms by 4. So let's move it down here, and then let's divide. Let's now divide all of this by 4. So 12 divided by 4, that is 3. And then just simply copy the variable a raised to 6 plus 8 AB divided by 4. 8 divided by 4 is 2. And then copy A times B minus 20b squared divided by 4. So 20 divided by 4, that is 5. And then copy the variable, which is b squared. Now again, let us check whether this factor is correct. Let's multiply. So 4 times 3, that is 12, times a raised to 6 plus 4 times 2ab. So only multiply 4 and 2, that is 8, and then copy a and b, minus 4 times 5, that is 20, and then copy the variable b squared. And still, this is our given expression, so therefore our factored form is correct. Okay, so that will be all about common monomial factoring. I hope you learned something from this video.